Hi dear friends, once again welcome back to heat transfer class. Today we are going to discuss about the unsteady heat transfer or transient heat conduction. So myself Muhammad Rafi from Assam Engineering College. So in the previous classes throughout our discussion we were talking about fin analysis or critical radius of insulation or the heat transfer rate equations through a slab, cylinder, sphere or a composite slab, composite cylinder, composite sphere. All those things we are discussing considering the heat transfer rate or temperature not varying with respect to time. So we were termed it as a steady state heat conduction, right? So in the first class itself, I told you heat transfer got a lot of real time or real life applications. Whatever heat is flowing in our day-to-day life, you can categorize whether it is steady or unsteady. So in real life, most of the cases will be of unsteady state. That is, for example, just boiling an egg. So that egg temperature will be changing time to time. Initially, it will have some temperature, then it will be increasing. Or if the boiling egg, you are just trying to cool it down for eating, right? In that time also the temperature will be gradually coming down. So there also it is a temperature or heat transfer rate variation with respect to time. So this set of example or this set of application we will call it as unsteady heat transfer. So the analysis will be entirely different. Let's try to see how these things are different in different cases. So basically we are in a TEQIP 3 faculty initiative with the motto of Let's Crack the Gate. So I hope you guys are getting benefited from these lectures. So please like this video, comment your opinion, and also share with your friends. So for better reach of this video. So basically, the unsteady heat transfer rates for any case, if you take the scenario for any body which will have a volume and a density and thermal heat capacity and a particular temperature, and it is surrounded by a ambient, it is T infinity. So in some case T will be greater than T infinity, so there will be a cooling process will be taking place, heat will be flowing from the body to surrounding. Or if T is less than T infinity, then the body will be getting heated up. So basically heating or cooling both are the only the direction of heat transfer is different, but rest of the equation, governing condition, everything will be same. So for an unsteady state, what we are going to study? For an unsteady state, the temperature is a function of the position as well as the time. So for any body, suppose my body myself, at this particular time, my body, some portion like some palm of my hand will be of some temperature. There will be a small difference, right? Or the head or the tip of my nose or whatever the body parts will be having different temperature. Similarly, under different time also it will have a different temperature, right? So we are going to analyze this scenario. Understood? So can you just recall some example? Basically, the cooling of IC engine or heating or cooling of metal billets. Suppose you are dropping hot iron or some quenching process. All this thing you might be studied in material science or you are going to study in other subject. So in wherever the heat transfer happens, it will be either a steady state condition or unsteady state condition. So we have already got enough idea about the steady state condition, how temperature profile is varying, how heat transfer rate is varying. All the thing we have analyzed in the previous lectures. Okay, now we are just like I said, the unsteady state is the most common in our day-to-day life. But in this subject, heat transfer or heat and mass transfer subject, undergraduate subject, we are just laying foundation for the study. Okay, so here also I will not go in depth to the analysis. I will just give some brief idea about unsteady heat transfer. And today's lecture I will be discussing about the theory related to unsteady, and also I will be discussing a couple of questions from the previous year questions. Then in the next class we will discuss little more questions. Okay, so for gate point of view or competitive exam point of view, this topic got a lot of relevance, very important, because in the previous year gate also there was 2 mark question numerical type regularly they were asking. So we can expect in 2022 or 23 or 24 there will be at least 1 or 2 question for at least 1 or 2 set of question paper. Okay, so let's move on. So basically for unsteady heat transfer, this is very important for a discussion which is called a lumped heat capacity analysis. So what is a lumped heat capacity? So unlike the previous case I was telling the temperature of the body will be different throughout. Taking my example, the tip of my nose will have some temperature, this palm will have some different temperature, small difference. Okay, so for any body, if I am considering a very big, large body, definitely there will be some variation temperature. At this point, it will be having some temperature. It will be, suppose it is 35 here, it is 40 degrees Celsius here. So there will be internal heat transfer within the body. All this thing will be there. So in order to make our analysis easy, just like in case of the one-dimensional conduction, we were taking some assumptions, right? So similarly in unsteady heat transfer also, it is not an assumption, but in real life there will be, I am just considering the internal thermal resistance or the conduction within the body is negligible. Okay, so that means there is no temperature variation within the body, but it is varying with respect to time. So for example, if you are taking the boiling egg, so whole boiling egg body will be of same temperature, but it is varying with respect to time. That is a case of a lumped heat capacity analysis. We call it as a temperature of the body uniform throughout its mass, but it is varying with respect to time. I hope you are you are able to follow, right? Clear? Now, how you can assume any unsteady state whether it is a lumped heat capacity or not? So in order to define this criteria, so in order to differentiate two process, whether it is a lumped heat capacity analysis or not, so they have decided, the scientist has proposed a minimum criteria by defining a non-dimensional number that is called a Biot number. So if Biot number is less than 0.1, if Biot number is less than 0.1, then you can consider it as a lumped heat capacity analysis. Now, what is this Biot number? Right? Now that got some relevance. Now let's see what is a Biot number. So Biot number is basically defined as a ratio of internal conductive resistance to external convection resistance. So for example, if you just talking about any body, which is, I am just talking about a body just like this, right? So it will be interacting heat with the surrounding by which mode? It will be by convection. Okay, and within the body, what is the mode of heat transfer? Because it is a solid, so for a solid it will be definitely, it will be a conduction. So here this is very important in the definition of Biot number. This is, I am talking about the solid body, thermal conductivity of the solid. Okay, and this is convective heat transfer coefficient with the surrounding. Okay, I hope it is clear. Now this is the expression for finding out the Biot number for any case, HL by K. So this will got like if you are talking about another dimensional number, Nusselt number in free convection, that is we are going to study in the upcoming lectures. So Nusselt number also is have got some definition, HD by K or HL by K. So both have the same in look, both are looking similar, but both have the different meaning, because in Biot number we are talking about the thermal conductivity of the solid, but in Nusselt number we will be talking about the thermal conductivity of the medium. That is the main difference. You will learn in more while we are discussing about the free convection. Anyway, so what is the physical relevance for any dimensionless number? That also you are going to study in Buckingham pi theorem, dimensional analysis. So for there are many dimensionless number or the numbers, we are just defining new numbers in order to make some comparison. So all these number will have some relevance in our engineering discussion. So what is the relevance of a Biot number? So Biot number, you can see from the definition, it is HL by K. So Biot number should be less than 0.1 in order to consider any heat transfer process as a lumped heat capacity analysis. So how, at what condition Biot number will be less than 0.1? Yeah, from the expression you can see, in order to have a very less Biot number, the body should have a very high thermal conductivity, right? Or the body should have a very high, very low convective heat transfer coefficient. So under this scenario only, you will consider a Biot number or the lumped heat capacity analysis. Okay, so we will consider lumped heat capacity analysis only if the body have the high thermal conductivity as well as the small size of the body. So how you will define this small size of the body? This is also very interesting parameter, this characteristic length HL divided by K. So our body will be of some shape, right? So it will be either a cylinder or a slab or a sphere, all those things. So what will be the characteristic length? So have you heard of this term characteristic length? कहीं पे सुना है क्या कैरेक्टरिस्टिक लेंथ के बारे में? So in our physical or in engineering problem, it is quite often we will be defining some characteristic length, whether it is in case of a free convection or in case of, suppose you are talking about the Reynolds apparatus or Reynolds analysis. What is the Reynolds number? Which we use to differentiate different types of flow, right? Whether it is a laminar flow, turbulent flow, or transition, you will term it as based on the value of Reynolds number. So similarly, Biot number is used to differentiate between a lumped heat capacity analysis and other analysis. So in Reynolds number, what was the expression? Rho v d by mu, right? So that d or that d will be coming out to be as a characteristic dimension. Suppose if you are talking about a rectangular channel, then it will not have a particular diameter, right? It will be varying across the cross section. So how you will define the diameter there? So for that we will have some definition for characteristic diameter or characteristic length. In case of a free convection, free convection across a pipe or a free convection over a flat plate, in that case also characteristic length is very much important. Anyway, while we are defining the Biot number, what is the definition for characteristic length? It is nothing but the volume divided by area. Then only it will have a dimension of a length, right? So for volume, what is the expression in case of a sphere? Suppose I am talking about characteristic length of a sphere. What is the volume? Volume of a sphere? Yes, 4 by 3 pi r cube. What is the area? 4 by 3 pi r cube, and it is 4 pi r square, area of a sphere. So it is coming out to be r divided by 3. Similarly, what is in case of a cube? In case of a cube, what is the definition? What is the expression for a volume? Volume is a cube, right? If the size is a, it is a cube. And what is the area? 6a square, right? 6 face is there. Each for a cube, each face will be a square having area a square, right? So it will be a divided by 6. What in case of a cylinder? Cylinder, if I am considering a long cylinder, so while we were discussing the first question in my lectures, some people will got some confusion why I was omitting the end area. So this is in the case in the YouTube comment I have told there that if the length is very long, we can omit the end surface because that convection through that surface will be comparably very long, right? So here if I am talking in case of a cylinder, what is the volume? Pi r square is the area, pi r square divided by L. What is the surface area? 2 pi r into L. So I can write it will be r divided by 2. So basically this is everybody should remember what is the characteristic length for sphere, cylinder and cube, because in every cases whenever you are trying to talk about the Biot number, then you should know how this characteristic length is calculated. Okay, are you okay? So let's move on. So another dimensionless number, that is a Fourier number. So it also got some relevance. So before going to talk about the physical relevance, let's try to identify what is a Fourier number. So these numbers also, Reynolds number rho v d by mu, or the Biot number HL by K, or the Fourier number alpha tau divided by L square. All these things are as per the observations in while doing some experiment. So instead of repeating the same equation rho v d by mu, rho v d by mu, I can replace the single number Reynolds number. Similarly here also Fourier, they have just proposed, instead of repeating the calculation alpha tau divided by L square, they are just replacing this with a single digit number or single number. So there is no much, you should not be confused. Okay, and I hope while we are learning about the non-dimensional or dimensional analysis, Buckingham pi theorem, all those things, you will get a better idea, a clear picture about the dimension, what is the importance of this kind of numbers. Anyway, so what is the dimension of this number? Definitely it will have different dimensions, but this number, some dimensionless number, sorry, so some numbers they don't have any dimension, but some cases, some unique cases are there, the numbers got itself some unit as well as some dimension. So anyway, Fourier don't have any dimension. So what is the physical significance? So it is just giving a idea about the heat penetration depth. That means, for example, if I am talking about, suppose for any medium, if I am just filled with water is there, I am just dropping a steel bowl of having temperature 100 degrees Celsius. At the same time, I am just dropping another body. Suppose instead of steel, I am using gold of 100 degrees Celsius. So if I am just dropping both into this, what will be the scenario happening? That is the question. So it is just basically about the heat penetration, how fast this heat will be diffused within the body. So what is this alpha? It is called thermal diffusivity. By definition, it is the ratio of thermal conductivity to thermal heat capacity. Okay, so this you guys should not be getting much more should not be confused about these dimensionless numbers. These all are defining as per some requirement, depends on the scenario. So Biot number and Fourier number basically defined in order to make our analysis in unsteady heat transfer a little more easy. So in this expression, I hope all the parameters you are familiar with. Again, I will just repeat. Alpha is the thermal diffusivity, K by rho Cp, and tau is the time. Under what time heat transfer is or heat is penetrating to that body. And L is our usual characteristic length. Okay, so instead of alpha, if I am replacing K by rho Cp, so K is the thermal conductivity of the material, or rho is the density, and Cp is the heat capacity. So volume, like rho Cp, you can see mass per volume into specific heat capacity. Okay, so anyway, this is the all about the lumped heat Fourier number as well as the Biot number. Now just like in the previous case, while we were talking about the conduction also, what we were doing, now we got some idea what is happening here. Suppose for any body in lumped heat capacity, temperature is varying with respect to time, so it will be coming in contact with some ambient scenario T infinity, and there will be some convection with the surrounding, right? This is what we have studied. So convection or radiation, usually I will consider convection only. So with the convective heat transfer coefficient H. So for any body having a volume and a density or a mass, and if it is coming contact with another surrounding with the temperature T infinity, so it will start interacting heat the surrounding. So in case of a lumped heat capacity analysis, there is no temperature variance. That means temperature at this point, suppose initially Ti, Okay, so this point also will be Ti, this point also will be Ti, this point also will be Ti, this point also will be Ti. But if after some time, if this Ti become T, some other temperature, then the whole body will be attaining that particular temperature. That is the meaning of lumped heat capacity analysis. That is, lump means just a group of things, just like that. Okay, so all body will be attaining the same temperature, that is the meaning, but depends on the time it will be different. So for this case, if I am, for any case, if I am just drawing writing the energy balance equation, if I am just writing the energy balance equation, whatever convected, whatever heat is convected will be resulting in the temperature drop of the body, right? So if I am just writing in order to, I will just make the screen bigger. So if I'm just writing the energy balance equation, whatever Q convected will be equal to rate of change of, how this convection taking place, rate of change of internal energy of the body, right? I'm sorry for my bad handwriting. So what we are saying, for this Q convection, what will be the expression? H A into T minus T infinity, whatever may be the temperature at some particular time, should be equal to minus mCp dt by dt. This will be the temperature drop. So if I am just usual in conduction also, we have just separated the common parameters. So if I am writing HA, m is the mass, so density into rho vCp, right, into like this, into dt equal to minus temperature difference T minus T infinity. So this is the scenario at any particular time, at any random time, this will be the scenario. So if I am just wanted to see what will be happening throughout any time T, starting from initial state Ti to T, and temperature is varying from Ti to T. So if I am just use the integration technique, so this whole body HA by rho VCP, which will be coming out to be a constant, and HA by rho VCP into T should be equal to minus logarithm of T minus T infinity Ti into T. Okay, so if I am just elaborating this, logarithm of T minus T infinity minus this minus will be there, okay, or I just replace that minus. I am just removing that minus. So if I am just replacing Ti minus T infinity logarithm of T minus T infinity. So I can write logarithm of A minus log B equal to logarithm of A by B. I hope you guys already know this. Similarly, log A plus log B, I can write logarithm of A into B. So using this, I can write logarithm of Ti minus T infinity divided by T minus T infinity equal to HA by rho VCP into T. Okay, so in order to remove this logarithm on this side, if I can write Ti minus Ti minus T infinity divided by T minus T infinity equal to e to the power HA by rho VCP into time. So this is a beautiful equation. Everybody should remember. Throughout our analysis, we will be recalling this thing. So what is the meaning of this thing? This have got the expression for temperature profile. Okay, so at any particular time T, it will give the temperature T. Okay, so if you know the H value, area, density, volume, and specific heat capacity of the body, and the initial condition Ti and surrounding temperature T infinity, then you can always find out that particular temperature. till now, while we were talking about the uh, conduction through a slab, conduction through a sphere, or the fin analysis, everywhere we are not concerning or we were not discussing about the time. We were finding out the temperature at different point. It was about the position in case of a fin analysis. In case of critical radius of insulation also, we were not bothered about the time. But now, in a very simple way, or in a very primitive way, we are just trying to find out the temperature at any particular time, and in case of a lumped heat capacity analysis. So this expression gives a brief idea about the temperature profile at any random time. Okay. So let's discuss about this expression. This is nothing but we just derived this expression. Now I am just going to do a little more. Uh, I am just playing with this. So always remember this ratio is Ti divided by T infinity. Okay, Ti minus T infinity, initial temperature difference, divided by T by T infinity into HA by rho v Cp. It is a constant into time. So in here HA by rho v Cp, instead I am just playing area and volume. Volume को मैं L into A भी लिख सकते हैं ना, ठीक है. So I am just replacing that thing, and so this area and area will be getting cancelled, and again I am multiplying with the L on numerator and denominator. I am just trying to find out some correlation. Okay, this is a just a mathematical operation, and in order to draw a little more conclusions. Okay, so here I am just replacing I am just rearranging this expression HL by K and K tau divided by rho Cp by L square. So it is find out to be K by rho Cp will be our thermal diffusivity. And regarding thermal diffusivity, we are going to discuss in the next lecture, which is heat transfer with the steady conduction with the heat generation. There we will be discussing little more about the physical relevance of thermal diffusivity. Now I am just recalling, like just briefly talking about the alpha, but there we will be talking why alpha is relevant, how we can differentiate material with respect to alpha, because alpha is a thermophysical property, just like the convective heat transfer coefficient, which was also a thermophysical thermal conductivity, which was a thermophysical property, where the convective heat transfer coefficient H is not a thermophysical property. Anyway, here I will be getting an expression Biot number and Fourier number. So this expression, the temperature profile, I can directly write it is a exponential of Bi into Fourier number. So what is the relevance of this expression? So basically this expression can give a lot of idea for different object will have different Biot number or different Fourier number. So you can make a graph with respect to time or with respect to temperature, all those things. So, okay, so like I said, this is a very day-to-day life unsteady heat transfer or transient heat transfer got a lot of application. So as the applications are increasing, the complexity of analysis also will be increasing. But as a BTech student or a graduate level, we are not bothered to go in depth to the analysis. But I believe, I hope, if you get an opportunity to crack GATE and get into IIT or NIT or any other institution for masters, then you will get a better opportunity to learn more or more complex analysis. Okay, and that is very beautiful if you learn computational fluid dynamics, CFD, and try to correlate this subject heat transfer, and do now we are dealing with the equations, right? For every cases we are just finding out some parameters and finding out the value. But there is another way of analyzing all these cases, that is a numerical method. How these softwares work, how suppose a software called ANSYS Fluent. Have you heard of ANSYS Fluent? So for mechanical, if you are a thermal student, definitely you are going to deal with the ANSYS Fluent extensively in your masters. So there also how this software can calculate for some scenario, some boundary condition, this temperature at this particular point will be this much, and another case will be that much. How this computer will be able to understand? That is by numerical method. right? We will be doing some coding. So the coding, we will be doing some discretization. All this thing is going to happen. So unsteady heat transfer, it got a lot of wide application, and it will be very much relevant in the higher study. But here now we are just talking about the GATE exam point of view or your graduate level. Okay, so I am not going to talk about the complex analysis. I will be just briefly talking whatever necessary requirement required for your competitive or university exam level. Okay, so let's move on to that discussion. So basically, this is the expression for a lumped heat capacity analysis. Everybody should take a screenshot and include in your short note. I hope you guys are rigorously working on preparing the short note. If you are feeling demotivated, guys, this is the best opportunity. You are sitting in your home or in your comfort zone, but remember, everybody are in the same scenario. So people are trying very hard for their competitive exams. So you should not be sitting lazy, or you should not waste this opportunity. Try to utilize this opportunity in a positive way. Okay, so like get some motivation within, like from yourself, and try to work on it. And definitely your future will be very bright. Once you work very hard, very sincerely, definitely you will get some output in the future. Okay, so let's with a positive mind, let's move on. So this is all about the lumped heat capacity analysis. So if I am just trying to plot the temperature variation, suppose in case of a heating, right? If I am just starting to heat any body, suppose the temperature initially, this is a plot between temperature and profile. So it is 100 degree Celsius, and I am started to heat, then the body will be getting heated into 150 degree Celsius. That 50 degree Celsius difference in a time difference of maybe 10 seconds. Again, I am keeps on heating the same body, right? I have a metal bowl. I started to heat starting from ambient temperature to 100 degree Celsius, then to 150 degree Celsius. Again, I am heating. Again and again and again, I am heating, and I am just checking the temperature. We have got a lot of way of checking the temperature, right? Either a thermometer or optical thermometer or infrared thermometer. All those things are there. Now, if I am just started recording the temperature and the time, how much time it took to reach that temperature. So suppose from 150 to the same thing, suppose 200. Then if this distance is 10 second, then it will be 15 second. Or if I am talking 150 to 200 or 250, then it will be 25 second. That means the temperature gradient, once in the initially it will be exponentially increasing, right? For a heating, or in case of a cooling, it will be exponentially decreasing. How you know? We already know from the expression, it is clearly visible. The temperature variation is exponential with the time, right? Asymptotic with the time. So this is the overall discussion regarding the lumped heat capacity analysis. Now again, one more parameter which is called thermal time constant. This is very important. If I am just writing down the dimensions of density, what is the dimensions of density? If I am just writing down, do the dimensional analysis, you will get it as a second. This is the expression, rho VCP divided by HA will have a time constant. That we call it as a thermal time constant, which got a dimension of a time, and it indicates how fast the body responds to change of environmental temperature. So this is very important. In the sense, suppose we are talking about the thermometer. Can you just recall how once you go for a hospital and you are having बुखार लग रहा है तुम लोगों को, तो बुखार के वजह से हम अगर हॉस्पिटल में जाएगा, जो नर्स या डॉक्टर पहले क्या करेगा, हम लोग को एक थर्मोमीटर दिया जाएगा, तो फिर वो क्लीन करके हमारा टांग के नीचे रखे, फिर बोलेगा थोड़ा देर ऐसे रख लो, ठीक है? तो थोड़ा देर के बाद वो उठा के फिर ऐसे ऐसे मतलब ऐसे करके फिर चेक करके बताएगा आपका बुखार कितना है, बॉडी टेम्परेचर कितना है, ठीक है, इधर टंग का नीचे रखेगा और नहीं तो यहाँ पे आर्मपिट में रखेगा, ठीक है। तो दिस इज actually they are just trying to deal with the time constant. So time constant is that how fast the body respond to the change in environmental temperature. Suppose this is the thermometer. If I am keeping under my tongue or armpit, what will happen? This thermometer will have a bead shape, right, a bowl shape, and which will be filled of normally mercury. So this mercury will take some time to absorb that heat. That is all about the time constant. It may, like, I'm just trying to correlate this thing in our day-to-day life. So if during the pandemic time we are extensively using infrared camera, right, for checking the temperature. So how you will check that temperature? It don't have much time constant. Whatever the moment it is coming contact with you and the radiation going there and coming back, and there will be some sensors, then they can find out what is the surface temperature. But in our laboratory and all, we will be dealing with the thermometer extensively. So every time you have to keep some particular set of time in order to achieve that time constant. Okay, so for a mercury thermometer in hospital, usually it is 80 seconds. So the doctor or nurse will ask you to keep that thermometer at least 60 or 50 seconds, right? Or 80 seconds, depends on the thermometer. So basically, in order to have the, like, in our usual practice, we will prefer to have a very less time constant, so that we will not be waiting for the taking the temperature response. So in thermocouple also, in your lab, in heat transfer lab or in fluid machines lab or any other lab also, if you are dealing with the thermocouple, that also got some time constant. It will need some time to attain that equilibrium with its corresponding temperature. Anyway, I'm just discussing this thing which you might have or you should observe in the upcoming days. Okay, that whenever you are coming contact with the thermometer, just try to check what is the time constant. Anyway, this is all about unsteady heat transfer. Now let's, in your university exam point of view, in your university exam, if you are coming across any unsteady heat transfer problem, you have to follow this algorithm. That is, first of all, you have to check the characteristic length. In case of a cylinder slab, we have already discussed how this can be calculated. Now once you know the LC, you can find out the Biot number, because H and K will be already given in the question. So if this value is 0.0 less than 0.1, then only you will proceed with the lumped heat capacity analysis. If it is greater than 0.1, you cannot use the lumped heat capacity analysis. There are other complex equations to deal with that. So usually in our university exam, normally all the questions will be under lumped heat capacity only. That means this is just a namesake. You are just checking Biot number is less than 1.1 or not. Okay, so once you know the Biot number, then you can either calculate the alpha value. If it is given directly, then it is fine. Otherwise, from the idea of K, rho and Cp, you can find out what is the alpha value. And if you know the alpha value, you can either use alpha, this find out Fourier number, or you will use T I minus T infinity divided by T minus T infinity equal to e raised to HA by rho VCP into tau. This expression you can use. So basically, I'm just recalling an algorithm which you can follow while in your university exam point of view. So, but in our GATE exam point of view, you need not to check Biot number every time. You can directly go for solving, because that will save your time. So let's try to do this problem. Everybody try to do. I am also going to try. So this is a GATE 2004 question, and in here most of the questions will be directly like straightforward. So don't get confused by just seeing the question. And remember, in our analysis there should be three temperature: Ti, or the temperature at that particular time, and Ti initial temperature, and the surrounding temperature. So don't get confused about this three temperature. Okay, rest of the things already given. So let's check how to solve this question. So it's a spherical thermocouple. So we got it is a sphere. The shape is sphere, which will play a vital role while calculating the volume and area. So diameter is given in millimeter. For a measurement of temperature of gas stream, the convective heat transfer coefficient. This is what H value, right? And the thermophysical properties of the thermocouple, K value is given. Thermal specific heat capacity, how do you know? Joule per kilogram Kelvin. So, okay. And density in kilogram meter cube. Initial temperature is 30 degrees Celsius. So Ti is 30 degrees Celsius. And this is placed inside a hot stream. So that is the ambient temperature, right? So surrounding temperature is 300 degrees Celsius. And then the time taken the bead to reach 298 degrees Celsius. So that is what we are looking for. So the time required, that is our question. So people are like they were some students who were contacting me, texting me on WhatsApp, and they were saying they are facing problem while solving numericals. So this is quite often, guys. Don't worry. Fluid mechanics, heat transfer, thermodynamics, refrigeration, air conditioning, theory of machines, they have very little portion of equation. Mostly, you should have a clear idea about the concept, and there are some set of equations. So you should remember those equations, and if you know these two things, then you have to start doing problems. So that is why I again and again emphasizing everyone, just prepare your equation book, because if you have a very good equation book, you can solve as many questions in a very less time. You can in the initial stage, I will recommend you can even refer your equation book. You need not to by heart all the equation, but by practice you will learn. You will be familiar with those equations. Okay, so nothing is possible in a single day. Everything is possible in a gradual improvement. So you have to analyze yourself. You only know your strength and weakness. You only know what is your financial background. You only know what is your home situation, whether you have comfortably you can sit and study, or you have some problem in your home. All those things, it is purely personal. But guys, those things will be there with everyone. I also have my own problems, you have your own problem, everybody have problem. So you should not be demotivated, or uh, you should not be feeling back, or you should not be feeling lazy just because of your situation. These things are bound to happen. That is nothing of out, like all are out of our control. But you should know, you know what are the strengths you have. So focus on your strength. Try to work to improve your strength, and try to nullify your weakness. Definitely one day will be yours. Definitely you are going to achieve your career goal with the support of your family or friends, or even without any support from your family or friends. You are bound to bring the change what you are seeing in your life. Okay, so basically I just wanted to share a couple of more things we will be sharing in the upcoming classes, because guys, me also, or all the teachers who are teaching here, or whoever be you consider as a successful person, everybody have been going through all this kind of scenario. Okay, nothing comes free. And remember this course, I know many of you are watching this course in YouTube, and you will be finding this is free, so you will not be that serious. Guys, even though you are getting these lectures free of cost, all this video we are not charging, or not even we are monetizing our YouTube channel till now. So you are getting this free of cost. So you should not be feel like this is the quality is not good. It is not like that. People, especially teachers, they are very much qualified, they have cracked this exam, and they are devoting their time. That is the cost of this effort. I myself have another work. We are working in our own college, we are teaching subjects in that college. Apart from that, we will be engaged in the NBA accreditation, other documentation work. We have our family, we have our own other situation, but still we are trying to bring a change. We are trying to provide some free coaching to those who are desire, like there will be some students they are desiring for this content. So we are putting our effort, we are spending our time, we are spending our uh, other resources just to give you some quality content. So don't think this is coming free. This is not actually free. It is coming with the cost of our effort. Okay, so this will be beneficial to everyone if only if you are just seriously prepared. So I know some days the number of views are very low in the YouTube, but I am not bothered about those things. If one student is getting benefited, I will be happy. So basically, all our effort will be beneficial only, or our effort will be effective only if it is helpful to you. That is why I am again and again repeatedly telling you, guys, you solve the problem by yourself and try to identify your weakness and try to contact that faculty, or you try to get help from your friends or your concerned faculty from your institute and try to improve yourself. That is the ultimate objective. Okay, so let's move on. It's been quite some time I have been giving भाषण, right? ज़्यादा देने से भी अच्छा नहीं लगता. ठीक है. So basically our equation is Ti minus T infinity divided by T minus T infinity e to the power HA by rho VCP into T. So the question is finding out the temperature, time T. So what is this expression? If I am just substituting all these things, Ti is 30 divided by 300 divided by T is 298 divided minus 300 into e to the power. Guys, आप लोग भी कर दीजिए, क्या मिल रहा है बता दीजिए कमेंट पे आप लोग का, what is the answer you are getting. This will be usually a straightforward question, but the equation you can see it is quite lengthy. So be careful about the unit, be careful about the value. H value is 400. In case of a sphere, A by B area is 4 pi r square, V is 4 by 3 pi r cube. So I can see it is 3 by r, right? So it is into 3 divided by r कितना है पॉइंट इसका by 2, 353, right, into 10 to the power minus 3, and density कितना है 8500, C value 400 into T. Now what is the value? Now it is clear, right? Now if it is directly, you can do the calculation. It will be 270 divided by 2. So if I am doing this calculation, you will get T equal to 4.9 seconds. That is option number B. Right? So this was a straightforward question. Let's try to do another similar question which is asked in the GATE 2020. Guys, that is the relevance of this topic. GATE 2020. Very recently they have asked for how much mark? 2 marks. So this 2 mark can change your rank or can affect in your performance very well in the GATE exam. So let's read the question. A small metal bead. So from this you should identify it is a sphere. Initially so like I said, there will be 3 temperature. There will be 3 temperature. So Ti is 100 degree Celsius, T infinity placed in a stream of fluid. So that is a surrounding temperature 20 degree Celsius. Attain a temperature T, that is some particular temperature at some particular time 28 degree Celsius, and the time is 4.35 second. Okay, are you able to follow? So let's try to solve. Rest of the things are there. Directly we have to find out H value. So again the equation Ti minus T infinity, T minus T infinity e to the power HA by rho VCP into T. All these things are given. I directly write Ti 100 minus 20 divided by T minus T infinity, 28 minus 20 equal to e to the power. H value is not given, we don't know. A value, A divided by V. Okay, so A divided by volume will be 3 times R value. R is 0.5 into 10 to the power minus 3, and rho value it is 8500. Density CP value 400. Okay, so this is also a straightforward question. If I am just trying to solve it, this is if I am just substitute apply the logarithm on both sides, I can easily get the H expression. H value will be coming out to be under this case 299.8. I have already just done my calculation by myself, so I am just referring to that. So this will be the H value watt per meter square Kelvin. So guys, in 2020 2 mark question. So if you know this expression, you will get the answer correctly. Okay, so take this topic very seriously. That is why in the next lecture also I will be solving a lot of questions, because numericals are very important in this area. You have every question you are just using one single equation, that is t minus t infinity divided by this thing. Okay, so let's move on to the next question. This is a theoretical question. Which one of the following statement is correct in IISc 2004? So in engineering service, usually they will be focusing on theory in the numeric prelims. Okay, so this is by reading you can see exponentially asymptotic to time, because we already know ti minus t infinity divided by t minus t infinity equal to e raised to tau divided by tau c, that is the time constant. So basically it is a curve like this, temperature and time, if it is cooling like this, if it is heating like this. Sorry. So this is a straightforward question. Let's try to solve the another question. What is the question here? Also just check how this can be solved. So it's a copper ball of mass 500 gram conjugated to water bath. So here cools from 5:30 to 4:30 in 10 seconds. What will be the temperature of the ball after next 10 seconds? This is a very common question in competitive exam, in state level and all, or in even ISRO. This is a very common question. So where the calculator is not used and all, you can use, like, even though exponential parameters are coming, but let's try to solve. So I told you, for every question there will be three temperature: ti, t infinity and t. So suppose in this case, if I'm talking, and time also, suppose in this case, first case, the when the water bath at 30 cools from 5:30 to 4:30, right? And the ambient temperature is 30 degrees Celsius, and under what time? In 10 seconds. Understood? This is one scenario in the initial stage. The question is, what will be the temperature of the bowl after 10 seconds? So this question you can solve in different way. Either you take next 10 seconds, then कितना टाइम हो गया शुरुआत से यहाँ तक? पहले 5:30 था, तो 4:30 तक 10 सेकंड ले लिया, तो दूसरा दोबारा फिर से 10 सेकंड, तो टोटल कितना होगा? टी आई विल बी 5:30 डिग्री सेल्सियस, टी इन्फिनिटी विल बी 30 डिग्री सेल्सियस, टी हम लोग को पता नहीं है, but time will be 10 plus 10 or 20 second, right? The same question you can do another way also. If I am drawing the curve, temperature and time, this is the scenario. Initially it is 5:30 and it become 4:30 in 10 second. तो पूछा गया है कि आफ्टर 10 सेकेंड में क्या होगा? ठीक है. So the same question, either you can consider starting from 5:30 to this temperature, so the time will be 20, or anybody, if some student think like, I will start with the temperature 4:30 initially, then the ambient temperature is saying 30 degrees Celsius. This one I don't know, but the time again he will take it as 10 seconds. Are you getting the point? So as a educator, as a teacher, I would like to emphasize all the way of approach on the same question. So here you need not to be confused. Any student, whatever common sense you are using, there is no problem. But the thing is that you have to use the right set of equations. So here, what is the equation? If I am using, our basic equation is ti minus t infinity divided by t minus t infinity equal to e to the power h a rho c by this thing. So tau divided by tau c, some constant. whatever may be the time constant. So here it will be same throughout this thing. So suppose I am just applying, for this case Ti is 530 minus 30 divided by 430 minus 30 equal to e to the power, and just term it as x, I don't know, whatever may be HA by rho Cp into temperature, time kitna hai 10. Okay, so this is an expression having like this. So similarly, what if in this case, if I am just substituting the same thing, Ti minus T infinity 530 minus 30 divided by T minus T infinity, that I don't know, T minus 30 equal to e to the power x into time is 20. So if you know the e to the power x, then the rest of the things are same, right? So if I am just, or you can say 530 into 530 minus 30 is 500, right? Divided by t minus 30 equal to, what is this value? It is 500 divided by 400 equal to e to the power 10x, or I can say 5 by 4. E to the power 10x will be 5 by 4. So if under this case e to the power 20x will be what? 5 by 4 square, right? So if I am just solving, it will be coming out to be 500 into 5 square is 25. 25 into, you can see, 20 into 16 equal to t minus 30, or I can say 20 into 60 is 3, t equal to 350. Yes, option number C. So similarly in this case, instead of starting with the 430, 530, I am starting with the 430. 430 minus Ti minus T infinity divided by T minus T infinity equal to e to the power x, 10x, right? So e to the power 10x, we already know it is 5 by 4. So if I can write like this, 430, 400 into 4 equal to 5t minus 150. So if I am doing the analysis, you will get the same answer, 350. So in engineering problem, this is quite often, there will be a lot of scenarios. Suppose I am talking moving from this point to this. So you can either come this way or you can come this way. So reaching the final point, that is very important, right? So if I am sitting in Kerala and I have to go to Assam or Guwahati by flight, so I can either go by, take a flight going through Bangalore to Guwahati, so Kochi, Bangalore to Guwahati, or sometimes I can go Kochi to Bombay to Guwahati. So it is, I have to start from Kochi, I have to reach to Guwahati. Whether I am touching Bangalore or touching Bombay, that depends on the scenario. So here also, in engineering problems, it is not always, the way is not that relevant. In most of the cases, you have to reach the particular destination as per our convenience. Okay, so whatever way you are approaching this question, you should get the right answer. You will get the right answer. Okay, so this is all about this question. So let's move on to next question. Another similar question. Let's see how this can be solved. A metal ball of diameter 60 mm. Everybody please try to solve. A metal ball, again it is a sphere, right? 60 mm initially at 220. The ball is suddenly cooled by a air jet. The heat transfer coefficient, all this thing is given. The ball temperature in degree Celsius after 90 seconds. This is also a question in GATE 2007. How much mark? 2 mark. So this question also could have been asked as a numerical type also. Instead of not giving the option, they could have asked in the numerical type also. So you should be ready, or you should be prepared to face any kind of question. Right? That is the beauty of, that is the meaning of preparation. So here, for any question, try to identify what are the three temperature: initial temperature, surrounding temperature, and the some that particular temperature. So here the initially it is directly given 220 degree Celsius and suddenly cooled by an air jet, that is the surrounding temperature 20 degree Celsius, and the this is we don't know, we have to find out, and rest of the things are given. So you can directly give ti minus t infinity, t minus t infinity e to the power ha by rho vcp into t. Okay, so if I am just substituting the value, ti is 220 minus t infinity is 20, t minus 20 equal to e to the power h value how much, h value कितना दिया गया, h value is 200, a by v I can write 3 by, for a sphere the same thing, 4 by 3 by 4 3 by r, radius is 30 into 10 to the power minus 3. Be careful about these units and all. Okay, sometimes they will give the diameter or radius, or sometimes give it in millimeter or centimeter or even meter. So always be careful, because that will make a lot of difference in our final answer. And if you give a little more attention in units and all, you can save a lot of time, because if you get an absurd result even though you know the equation, you will be confused, that will affect your confidence. So always be careful while attending the question regarding the units and all. Okay, so here what is the value ha, cp value is given as 400, and rho vcp delta t, right? So if you do this analysis, but any row how much is the value, 9,000. So it was a just straightforward question, but if you solve this properly, it will get 121.3. So basically you will get a temperature equal to 141.3 degree Celsius. So the option number Assam. So this is also a very direct question. So please practice so that you will not get any mistake. You will not make any mistake, because this is also 2017 last question also, which was almost here we have discussed 2020. So the same equation, there is nothing much difference in these equations, but only the values are different. So I hope if the similar kind of questions are asked in upcoming exams, you guys, my dear friends, you are going to rock it. Okay, so let's discuss a last question and I will be stopping here. So this is also a conceptual level question related to the heat transfer. So a sphere and a cube and a thin cylindrical plate. Okay, so the same material and same mass, initially heated to same temperature, and they are allowed to cool. So it is simply a time a body is there with a temperature T in initially, and it is allowed to cool. So what is the variation, how fast it is going to change, why, how, which one will be from Ti to this particular temperature, or from this particular temperature, which will be fast, that is the question. So here you need not to like how you can solve this question. So heat transfer, in today's lecture we have been discussing about the different parameters. Either you can take a consideration of a Fourier number or thermal diffusivity, all those things. So here I will not go in detail about all those things. You just think yourself, just a common sense. So here a sphere, a cube and thin circular plate, all of same material and same mass, that means same volume, राइट, सेम मटेरियल का डेंसिटी तो सेम होगा. सो अगर सेम मास बोलेगा बाय डिफॉल्ट ये क्या बोल रहा है, सेम वॉल्यूम का है. ठीक है, तो सेम वॉल्यूम का डिफरेंट शेप बनाएगा तो क्या डिफरेंट आएगा, सबका सेम सरफेस एरिया डिफरेंट आएगा. ठीक है ना. सिंपली इफ आई एम टॉकिंग, यू आर मेकिंग ए क्यूब, with the same thing you are making a sphere, with the same thing you are going to make a प्लेट, थिन प्लेट, दैट मीन्स इसका थिकनेस तो बहुत छोटा है. ठीक है, तो इन तीनों में कौन सा जल्दी जल्दी कूल होगा, तो आप लोग का क्या है आंसर, क्या है. फ्रॉम लुकिंग दिस और बाय जस्ट अंडरस्टैंडिंग दिस यू कैन सिंपली से व्हाटएवर हैव द एरिया मोर will be cool heat transfer will be more, heat transfer is directly proportional to area. तो जिसका हीट एरिया ज्यादा है उनका हीट ट्रांसफर भी ज्यादा होगा, उनमें से कूलिंग भी ज्यादा होगा. तो आउट ऑफ दिस which one got the highest area, this is also simple mathematics, right? You already know for area of this circular plate will be greater than area of the cube and area of a sphere. So from this you can say heat transfer of the plate will be more, heat transfer of the cube and heat transfer of the sphere. So the sphere, this will be plate का जल्दी होगा, फिर cube आएगा, फिर sphere आएगा. Are you able to follow? So the answer will be cube will be cooled faster than sphere but slower than the circular plate. Understood? So this is all about today's lecture, and I hope you guys have good understanding regarding the transient heat transfer. Again, I wanted to repeat, this is got a lot of applications in our day-to-day life, but we are just talking about the primitive idea. Okay, we are just discussing about the basic fundamentals about the transient heat transfer. There are a lot of complex discussion regarding to transient that you are going to learn if you got an opportunity to do any higher study. So basically in today's lecture I was discussing a couple of equations and couple of questions, and next lecture I will be continuing with the same concept because this is very important in view of the competitive exam point of view. So I will be discussing a little more different types of questions, and I will be talking about some other theory parameter which is included in our GATE syllabus. So I hope I will see you, like we will meet on the next class. I wish a very happy good evening to all and have a nice day to all. Thank you. Bye bye.